This is Friday, and Friday we have a new episode of the AWS Developer Podcast. This week we're talking about asynchronous GraphQL API invocation. We explain all that in a minute. Good morning, good afternoon. Thank you for joining us. Every Friday, a new episode of the AWS Developers Podcast in all your podcasting applications, Spotify, Deezer, Amazon Music, and all your Apple podcasts as well, and all the others. Please leave us feedback, little thumbs ups or little stars. Give us comments. That's how we know what are the subjects that are interesting for you. Talking about interesting subjects, this week I have the privilege, the honor to have a special guest from Australia, down under, but for you, I am down under. So it's a matter of relative perception. And everything is relative, like the other guy used to say. Derek Bingham, you're part of we are part of the same team. You're a developer advocate. And you recently blogged about a new capabilities of AppSync. It's to invoke asynchronous Lambda function. So you will explain us why the hell we want to invoke asynchronous Lambda function with AppSync. So what is the challenge we are trying to solve for developers here?
Well, hi, Seb. Pleasure to be here, first of all, on the AWS Developers Podcast. And yes, I am currently in Perth in Western Australia. So no matter where we are relative to each other at 180 or 90 degrees. So yes, I have recently blogged about the asynchronous capabilities of AppSync, but I think before really we get into it, we need to understand what is GraphQL, because for those people who are listening who don't know what AWS AppSync is, it's a managed GraphQL service that runs on AWS, and again, it's something that AWS manages, so you don't have to, but it manages a GraphQL server. So I think it's probably good that we start there, Seb, and I explain a little bit about GraphQL.
So most developers probably are comfortable with REST API, with GET, POST, and query parameters and things like that. GraphQL is a bit different. What is it?
GraphQL is a single endpoint. So like I know, Seb, you like myself used to be dabble or still do in mobile development, and so the real problem and challenge with people who are developing for mobiles where updates are hard is all of the RESTful endpoints, the posts, the gets, all of the ones that you had to code, all had different endpoints that you had to code with inside the client application. And so many years ago, Facebook came up with this standard called GraphQL, which would publish a single endpoint, and then behind that endpoint, you could call various actions on what's called a schema. So the actions, which line up quite nicely to post, get, and all of the REST actions, where you would have mutate to, if you wanted to change an object. You would have query if you would have wanted to query an object, so get a return of the object. And you have subscriptions, which would be a callback to the client based on a mutation. So they were the three actions you could do behind a GraphQL endpoint.
But the idea is to reduce the number of back and forth from the client, typically mobile or web application, to the backend. You do just one. You make just one API call, and then the server makes several API call on the back to collect all the data and bring back all the data in one round trip.
That's right, and what you can do is specify what you want returned. So rather than having all the things, so the entire kitchen sink returned in the response, in a GraphQL response, you could specify in the query what you want returned. So again, in a mobile context, or in a context where your application runs in a very constrained bandwidth scenario, then the GraphQL is the API that you want to use. And it's something I've been looking at for many years, actually.
Yeah, one of my favorite features is the subscription that you mentioned, because it's very easy to use from the client side to just subscribe to changes, and whatever is changing the state on the back end, your client will be notified through a callback mechanism saying, hey, that value has changed, and you can update your user interface in close to real time. I don't like to to call it real time because it might have different signification, but near real time.
Yes, depending on latency and all of those great things.
There was a challenge if you call a service that takes quite a long time to answer, or a service that is streaming a response from the server side. That's difficult to integrate right now.
Exactly. And that has always been a challenge, because the AWS AppSync adheres to the GraphQL specification, as does the standard type of server or name of server that also adheres to the specification. Is called Apollo server. Now, out of the box, an Apollo server does not implement subscriptions. When you have to actually code that up yourself, whereas AWS AppSync does, out of the box, have subscriptions. So that means, when you're building out applications that it didn't actually time out, if you do a common command response, request response, then using subscriptions is very powerful. As you mentioned, this is happening more and more. Primarily what we're seeing is applications or long-running background tasks, or say querying a large language model.
Oh, here we are. we mentioned it.
We are in Gen AI land here. And this is something that I've been absolutely looking at, is how we can use a facade pattern in front of various LLMs. And I know that Amazon Bedrock is that, where we are facading different LLMs, whereas AWS AppSync and GraphQL is a nice way to actually facade the LLM inside your application.
Let me pause and rewind here. So if an application wants to call a large language model, it can use the Bedrock API. It's one API for multiple models, so you can switch and try different models depending on your use case. And there are two options. Either the developer make the API call in the client application, in the web or mobile application, directly to Bedrock. That's the easy part.
Yes. If they really like coupling, that's an excellent thing to do.
That's exactly. Yeah, that's my question for you. Why we should not do that? But let me explain the second option first. It's to use the facade design pattern. So the client application call a generic API that you need to build, and that API in turn calls some backend service, including Bedrock. So what's the advantage of that facade pattern first?
Yep. But as I absolutely alluded to decouple the client from the backend logic and backend code, which we all know is excellent architectural style, because one should be independent of the other, for the simple reason if you want to deploy them independently as the client versions and backend versions. So the facade pattern is used primarily to do that, and what we see at the minute, as we start to explore Gen AI and applications that use it, is very simple demonstration apps, which very much are simple client commands straight into services like Amazon Bedrock, and that won't scale. Neither will it be production ready, because they're so heavily coupled together. So using facade like AppSync is the way to go.
And what's the challenge to integrate Bedrock into such a facade API? So Bedrock might take several seconds to generate a response, and most of the time you want to stream the response. So do not wait for the entire text to be generated, but stream and make it appear line by line in your client application. So that's difficult to do today without the new capability that we are going to talk about.
It's absolutely difficult to do. Not only that, because what you'll find is you can use models like possibly Claude Haiku, and you could actually build an application that calls into Bedrock and does the request response using REST, using Haiku, because it's quite fast. You might get away with it. However, if you truly want to use the power of Amazon Bedrock and use different models, so like a Claude Sonnet or a 3.5, that response time will be noticeably slower and your application will time out. And so this is where we want to think about AWS AppSync and GraphQL as a better pattern to call that Bedrock API.
And ta-da, there is a new capability that we introduced a few weeks ago that solves exactly that problem. So what is that new feature or new capability on AppSync?
Yeah, absolutely. So the async capability, I'll talk a bit about resolvers. So I haven't mentioned resolvers and what they are when it comes to GraphQL. So a resolver, think of it as we'll talk about patterns again, is an adapter pattern into a data source. So an adapter is simply a way of reading a data source and transforming the result so the calling function can understand it. So a resolver is like that. So you can have one or many resolvers in GraphQL. And so when you're building out a feature using GenAI, a resolver may be into Amazon Bedrock. So you really need a resolver into Amazon Bedrock, and the type of resolver you would use would be a Lambda resolver, because that's a nice way to call into Amazon Bedrock. Now, before this asynchronous change was pushed out by the AWS AppSync team, that would be really hard because the only way to do that would be synchronously. So the Lambda function would have to wait for a response on Bedrock, and as we've just discussed, that indeterminate, depending on the model that you're using. So this change of using async and having an async function resolver, it fixes all that, because what happens is the Lambda function that is the resolver can now return immediately to the caller, so AWS AppSync, and then continue to do what it needs to do. So that way, no matter how long the call into Amazon Bedrock takes, you will still be able to consume the response. Now, you're going to ask me a question here.
No, let's try to. I'm trying to build a mental picture diagram. It's an audio-only podcast, so I don't have a whiteboard here. But let's try to build that together. We have the client application calling the GraphQL server. In this case, the server is called AppSync. It's a managed service from AWS. That server uses a resolver, which is an adapter to any type of data source. With this new capability, the resolver, it's a Lambda resolver. So AppSync or the GraphQL server will call a Lambda function, and that Lambda function will call Bedrock in our example. Use probably the streaming API from Bedrock to receive a stream back, and the Lambda function code can return almost immediately as soon as the stream is initiated. First, is this general picture correct?
Yes, that's right, and what you're absolutely on the money there about what I fail to explain properly is you could still do this with AppSync before the asynchronous change. However, you'd have to do it using something like an SQSQ. Where the Lambda function would put the message or event into an SQSQ, and then another Lambda function would read that off, read the event, and then call Bedrock
to send a mutation to the client. But the new Lambda function, that Lambda first, I need to write it as a developer. It's not provided by AppSync. We are clear on that. I need to write it. What should I return synchronously to AppSync, and what should I do with the stream I receive from Bedrock? Where do I put that?
Yes. So to return, you simply return OK. So a very simple return.
I can do that.
Okay. It's just like saying, I got your request. I'm good. I've got this. And so you return that OK back. What then happens is you call Bedrock, and then the stream response, you manage through, as we talked about, mutations and subscriptions. The stream you can set up as a mutation. So as that mutation comes through in tokens, you can then chunk those and put them as a mutation back into the AWS AppSync server. So as you call back as a mutation, that will then create a subscription back into any registered clients. So that's a nice way of just streaming that response token at a time, or how many tokens at a time, depending on how you batch it, as a mutation back into the client.
I think I understand what you said, and I missed one big part of the picture. Maybe the listeners are missing it as well. It's not any type of Lambda function. It's an asynchronous streaming Lambda function that can return something synchronously and continue to progress. Because while you were talking, I was wondering if I return something, then my Lambda function is frozen.
It's dead. Yes.
So it has to be a special type of Lambda function that we call a streaming Lambda function, correct?
Yes, that's right. Yes. So that's very, very key. Obviously, yes. If you return from a Lambda, traditional Lambda, it will die. And so you need something to be alive to consume the stream and push it into an AppSync mutation or a GraphQL mutation.
So the GraphQL mutation is where the magic happens, because if the client subscribes to the mutation, the client will receive an asynchronous flow of events, of data coming from GraphQL. So that's the full picture.
That is the full picture, Seb. But there are some constraints.
Before going to the constraint, as a developer, what are the things I need to write to make this happen? The Lambda function itself, the resolver, and we can get into a bit more details about the resolver. And if I understand, I don't need to change anything on the client side. It's just a regular subscription to a mutation, nothing else.
That's right. So in an existing application, you probably have a client. In an existing application, you probably have the client set up already and a GraphQL schema. So you have your data objects all defined. And so you probably need to define a new object in that schema, maybe the response or the call it something that makes sense that you then need to render on the client. So you'd have to set that up and then make sure that's a mutation and the client is registered to that subscription.
So it's typically a string if the response is text, or an array of bytes if the response is an image, for example.
Exactly.
Okay.
Yeah, all can be supported.
And what do I need to change on the AppSync on the GraphQL server?
Well, it's pretty straightforward actually. So when you define a resolver, you define it two ways. I prefer doing it in JSON. Not JSON, JavaScript. And so you simply, when you're setting up the resolver, set it up as a invocation type of event.
That's a new invocation type in the resolver.
It is. So they've added a new field called the invocation type just for this. And so when you set up the resolver, you set the invocation type to event, and that's it. So once that's done, then you will be able to call the Lambda that sits at the end of that resolver in asynchronous manner.
Wow, that seems pretty straightforward.
Too easy.
Actually, yeah. Actually, there is just the Lambda function that I need to write. Another question before I know there are a few limitations, and we are going to talk about the limitation in a moment. But most of the AWS developers that I know are using a higher level library to access AppSync. I'm thinking about Amplify. Is it something already integrated with Amplify, or sometimes the teams need a bit of time to catch up with the latest change from AppSync to integrate that into Amplify? What would be your recommendation right now? We need to use the raw AppSync API, or can we use a higher level library?
So I haven't tried it with Amplify Gen 2, unless you have. So I can't for certain say that it's that's implemented using Gen 2. You have to give it a go and see if you can define. The key is the invocation type. So if you've got access to defining the invocation type to a Lambda resolver, then you can absolutely do it with any of the abstracted libraries like Amplify.
So this new capability is not coming for free. There are a couple of constraints or limitations that it's important as developer, designer, or even architect to know about the limitation, so that we can architect or design around these. So what are the key points to pay attention to when using this new capability?
Yeah, so I'll go through we've talked about the benefits, but I'll just reiterate those before I then go into things to remember. So if you think about the key benefits, it's that simplified architecture. So you don't need to add in the extra bounces or hops by SQS and separate Lambda, so that's removed. You don't. Also, what's really interesting, it has the error handling has a built-in retry, so that's really nice. And
on the client
also,
side, you mean for the subscription of the stream of data? Mm-hmm.
Yeah, so that's really nice. So that makes because let's think about it. This workflow is quite a sophisticated workflow for a client, and having something that already does most of the hard work for you is great. In my book anyway, having written some of these things. You have limitation-wise, we have limitations around the payload size. So we talked earlier about chunking that response, and you absolutely have to do that. You just need to know the limits. So the limit is for subscription responses is at the minute around 240 KB, which is quite a lot of text, which is what we usually respond with from an LLM and from Amazon Bedrock. So just bear that in mind, that you must be under 240 KB per subscription response, and just need to just work around that. I think that would be the key constraint that I would take away. It's just not going to, if you can, as you know, Seb, and I don't know if your listeners know, but you can also tune the size and the number of tokens that are coming back from Amazon Bedrock. So it would be nice probably to get these in sync with your client if you can, and if you can't, then you just gonna have to work with doing multiple mutations to carry through that 240 KB maximum.
Well, what I also love in this pattern and having a Lambda function acting as a client of Bedrock before returning the data to the mobile application is that Lambda function is not necessarily just a relay to Bedrock. There can be a lot of intelligent behavior. I'm thinking immediately about agents and workflow and conversational agents, where we can ask a model to do, I don't know, a classification task first, then call a couple of other API, and then call another model for that, and then another, and just return the final version, the final response to the client application. So it opens the door to a whole world of large language model orchestration.
Absolutely. I've been trying to beat this drum for a while, Seb, about using AWS AppSync GraphQL as an orchestrator and facade and focal point into Amazon Bedrock and large language models, and I hopefully this and a few more articles will instill a bit of curiosity to the developers out there to go and have a look and see if it actually is a good fit for the use case and it makes sense to them as well.
Do you have any starting point to recommend for our listeners? Obviously, I will link your blog article on community.aws in the podcast notes. So if you scroll down a bit in your podcast application, you will see the link to Community AWS, but maybe others as well, code repository, samples.
Yeah, so there is a number of AppSync. I think if you haven't used AppSync before, it's probably important that you understand how it fits together. So if you go to the AWS samples GitHub repo, there's some great AWS AppSync content in there. Also, like to give a shout out to Michael Liendo, who's the developer advocate for AWS AppSync. He has some fantastic content, including a video on this topic, and some great little videos on his YouTube on how to build applications using AWS AppSync. So Michael his stuff's really worth checking out. And then just try it. It's a developer technology. I like to call it and classify AWS AppSync and GraphQL as a developer technology. You gotta build stuff with it, otherwise you won't understand it, you won't grasp it. So go off and just get started.
And this fits in the whole larger picture of serverless services that scale down to zero, that you're not paying if you're not using them. AppSync is one of them. Lambda is obviously another one.
Exactly.
We are going to talk more about serverless in the AWS Developers Podcast next week with a couple of serverless DA and talking about the future of serverless in general. And in 2 weeks, we are going to talk with Sally, someone you probably know, Derek, about Amplify V2. So if you really want to connect all the dots together, you have like 3 episodes of the AWS Developers Podcast now. This one, the next one about serverless, and the last one about Amplify.
It's almost said like you planned it this way,
nope.
But yeah, if you're not building with serverless style technologies, then you're missing a really, really big trick. I'm very strongly opinionated in that way.
Yeah, I follow you on that side. I think a modern application, a cloud native application, should be serverless today. That's the way to build for the future. Thank you, Derek, for walking us around these new capabilities of AppSync. We started with a short recap of what is GraphQL and what is AppSync, why it's important for mobile application and web application to use GraphQL, and then we explained that new capability of asynchronous responses with asynchronous Lambda, and asynchronous is the way to code as well. If you remember the last keynote from Werner at reInvent, the modern developer is an asynchronous developer. So I hope you listen to this podcast episode asynchronously as well.
Nice.
And thank you for having listened us until the end, and see you next week to talk about serverless, and the week after to talk about Amplify V2. But right now, go build.